Because he has done so much for material science, Michio Kaku has said that the James Webb Space Telescope has seen 6 huge buildings that scientists didn't think were possible. These evaluations could give us new ways to look at what we know about the world. The finding is both interesting and difficult because it puts theories about how galaxies form and grow to the test. This confirmation by such a well-known expert shows how important these discoveries are. Michio Kaku is a famous scientist who is of Japanese and American descent. She is a physicist who is known as an expert in both classical experimental material science and quantum physics. Not like some of his more conservative colleagues, Kaku has been open to the James Webb Space Telescope mission's surprising findings. His eagerness to accept new discoveries and share them with the public shows how much he wants to help us learn more about the universe. That this well-known scientist has decided to talk about something that can't be denied is great. When the famous scientist talks about what the telescope found, he sounds excited and almost reverent, which suggests that these discoveries have really interested him. Kaku is a scientist who has always been willing to consider new ideas. He has always been open to ideas that go against what everyone else thinks. He knows that Einstein's theories of relativity and Newton's laws are basic, but they don't fully explain how complicated the world is. Kaku knows that the new telescope could lead to important discoveries that could move the field of cosmology forward, but many of his peers don't agree with him yet. This has made people who believe in the Big Bang Theory and people who don't believe in quantum physics worried. But Kaku seems to take these worries in a lighthearted way. 6 very large galaxies from the very beginning of the universe have been found by the James Webb Space Telescope. Even though they were only formed 200 to 700 million years after the Big Bang, these galaxies are very amazing. Each one has more stars than our own Milky Way. The astronomers who found these amazing cosmic objects have named them universe breakers because if they are proven, they would completely change what we know about the universe. These results suggest that the early world was much more complex and dynamic than was thought before. The most popular theory says that the universe was chaotic right after it started, and it took a long time for the first heavy things to form and become dense enough to give off light. It was thought that complicated structures like galaxies wouldn't form until much later. Some of these newly discovered galaxies are even bigger than the Milky Way. Their extreme brightness suggests that they are making a lot of stars every year, while our galaxy only makes stars sometimes. It is still not clear when the first galaxies formed, and scientists have not yet found an answer. At first, people thought there were only single stars or groups of stars that would join into bigger structures over time, creating smaller galaxies that changed over time. People used to think that big galaxies couldn't have existed so early in the universe's history. This has led to new questions about whether the universe is much older than we thought or whether complex cosmic structures formed much earlier. For conservative scientists who still have problems with this model, this situation is hard to accept. Some parts of the field even reject the finding outright and question the accuracy of age estimates. Kaku is aware of these disagreements and has said that some important experts keep many older theories alive even though they may be wrong. But, as Kaku says, experiments are the most important part of any study, but especially physics. We don't really know much about how the world came to be, which is pretty amazing. Kaku's comment shows how important it is for scientists to keep testing and validating their ideas. The main idea about how the universe came to be, which was first put forward in 1927, is that it started from a single point and has been growing ever since. At first, people had a hard time picturing a universe with both a beginning and an end. The idea of a universe that would never end was too hard to understand. Researchers are still having a hard time figuring this idea out. Science has shown over and over that it is important to be open to new ideas and re-evaluate old theories. It doesn't matter if these new results agree with long-held beliefs. Once upon a time, people thought that stars and planets were set in space and would not move. Now we know that everything in the universe is moving. Planets circle stars, stars move within their galaxies, and galaxies move quickly across the universe, but there are still a lot of things we don't know. This deep understanding of the world goes against long-held beliefs and shows how important it is for scientists to keep asking questions and changing the way they think. Scientists are told to accept results that are hard to accept and to remember that theories are not absolute truths until they are fully tested or confirmed by careful observation. Galaxies are moving away from each other, with this distance being measured in terms of how far away they are from Earth. This led to the Big Bang idea. This idea, which is called Hubble's law, suggests that the universe has been growing over time. Some cosmological patterns, such as the redshift of light from faraway galaxies and cosmic background radiation, seem to back up this idea. But it's important to remember that people who thought the Earth was flat, or that the Sun went around the Earth, used observational data to back up their ideas until new technologies made things clearer. We are seeing a similar thing happen now. Scientists were hoping that the James Webb Space Telescope would help them find answers about the Big Bang. Instead, it found 6 galaxies that didn't make sense. This shows that science is always moving forward, and that scientists need to be open to new discoveries and rethink old ideas based on new facts. The amazing discoveries have put what we think we know to the test and made us rethink long-held cosmological ideas. Redshift helps scientists figure out different measurements they need to make in their studies of the world. The color of light changes as light sources and viewers move away from each other. This is called redshift, which is also called the Doppler effect. To understand this, picture a car coming up behind you. The engine sound gets louder as it gets closer, but it changes as it moves away. This happens because as the car moves, the sound waves move with it. Light is the same way. When a light source, like a star far away, moves toward us, the light changes to blue. When it moves away, the light changes to red. Physicists have turned redshift values into rates and distances that can be used to measure the universe. However, even small mistakes in these readings can have big effects. Recently, the ways these calculations were done have been looked at more closely, especially since new information about our world has been found. These results make us carefully re-evaluate whether they are caused by real redshift mistakes or by scholars who don't want to accept the facts. This is a question that needs to be fully researched, and the facts and methods used need to be carefully looked over. The fact that measurement methods are still being looked at closely shows how scientific research is always changing.
Thanks for seeing it. As always, please leave your wishes in the comments. Thank you for watching the video. If you liked it, please like, share, and follow to get more videos like this. The trip of exploring the universe, with its huge distances and complicated celestial bodies, still interests and challenges scientists all over the world. Every new discovery, from the earliest ideas about the universe to the newest ones made possible by improved technology, changes the way we think about the universe and what we know. One of the most important questions in astronomy is how galaxies came to be and how they have changed over time. In a galaxy, the stars, gas, dust, and dark matter hold each other together like a city. Not only is it important to understand how galaxies grow and change over time, but it's also necessary to test the Big Bang theory, which says that the universe started from a single point that was infinitely dense and has been expanding ever since. This idea came from looking at how the universe is expanding and the cosmic microwave background radiation, which is thought to be the leftover heat and light from when the universe was very young. But new findings, especially those made by the James Webb Space Telescope, have called into question a number of the theory's most important ideas. With its very high sensitivity and clarity, the James Webb Space Telescope has found galaxies that look much bigger and further along than their age would suggest. The study team called these 6 very large galaxies universe breakers. They were formed only 200 to 700 million years after the Big Bang, which goes against what most people think about how galaxies form. The discovery of these huge galaxies at such a young age of the universe brings up interesting questions about how quickly the universe grew. It suggests that galaxy formation is more complicated and may happen faster than was thought before. In addition, this finding shows how important technological progress is in changing how we think about the universe. Astronomers have found parts of the early universe that they had not seen before thanks to the telescope's ability to look deeper into space and pick up faint light from faraway galaxies. These findings tell us a lot about the conditions and processes that shaped galaxy formation in the early universe. These results have effects beyond cosmology. They have led researchers to look at and improve previous models in order to better explain the variety and complexity of galaxies seen over very long periods of time. The study of how galaxies form is still a busy field that is changing as scientists look at data from the James Webb Space Telescope and other observatories. Every new discovery helps us learn more about how the world came to be and how it works at its most basic level. Finally, finding these 6 very large galaxies questions what we think we know about how galaxies form and how the universe began. It's also a big step forward in our quest to understand the mysteries of the universe. By pushing the limits of what scientists know, these discoveries lead to new discoveries and make us more interested in the universe's huge and complicated pattern.